So today we are going to discuss a new chapter, that is a chemical kinetics. Basically, chemical kinetics is the study of a rate of reaction. Rate means changes of. If we talk about its definition, so it is a study of rate of reaction, its mechanism, and effects which change the reaction. That is a definition of chemical kinetics. Now let's understand that definition, that what does it mean. Basically, chemical kinetics, it is a study of the rate of reaction. Rate means changes, means the change of reaction, like the change in the reaction, and all about its mechanism, and as well as the effects. And what type of effects? Like for example, there is a reaction, we are giving a temperature to that reaction, that what will be the effect of that reaction on that reaction, what will be the effect on that reaction. And for example, like another example if I give, that is if I increase the pressure or decrease the pressure of that reactants, so there will be effect. What will be the effect? We study in chemical kinetic. So the all the effects, its mechanism, the change in the reaction, all we study in the chemical kinetics. So here if we talk about, first of all, the rate of reaction. What is a rate of reaction? First of all, it is denoted by delta x upon delta t. Delta we use when there is a large, when there is a means there is a large change in the reaction, or we can say more change in the reaction, then we use delta. But if there is a small change, a less change in the reaction, we use a dx upon dt. But mostly we use that delta if there is a large change or the big change in the reaction. Now let's understand that equation, that why we denote it by this. It means that the change of the concentration with respect to time. With respect to time. That is known as a rate of reaction. Here we have created a definition that what is rate of reaction or the change of reaction, a change in the concentration with respect to time. Concentration of what? Concentration or the amount of a reactant. For example, like here if I wrote A plus B, that is a reactant and they make a product, that is C. Now the change of that concentration of that reactant with respect to time, that is known as a rate of reaction. Now they are like, here there are some terms, like here there will be the decrease the concentration of reactant and increase the concentration of product. And third point, they give that there will be the change between the reactant and product. For example, like this is a reactant and this is a product, we know. So when there will be a reaction, there will be the change in the concentration of it with respect to time, that will be known as a rate of reaction. First of all, there will be the concentration of reactant will decrease, because when there will be a reaction, obviously when they will consume, when these reactant will consume, a product is formed. So as they said that the concentration of reactant will decrease and there will be the increase in the concentration of product, means a product is formed. So that change is known as the change is known as the rate of reaction. There will be the change between the reaction and product, reactant and product. As we know, there will be a change when the reactant reacts, they form a product, and the product is like different from the reactant, so that is known as the rate of reaction. If we drive a equation that with respect to if we are driving a equation with respect to reactant, how can we drive? Like the reactant, the reactant, for example, that is A, that reactant will always in minus sign. Why? Because the reactant is decreasing. As the reactant is decreasing, so we put a minus sign with it to show that it is consuming, that A is consuming, that A is a reactant and it is consuming, so we are putting it minus sign with it. So if that is the formula, if we like drive a equation with this, for example, this is a reactant, so how we'll be writing it? Delta A. Now A will be, X is a reactant, any reactant, so here we are taking a reactant A, so that will be A, but it will be minus delta A. Why? Because we are showing that it is a reactant and we are showing it with a minus sign. Then with respect to time, so that is known as, that will be a equation with respect to reactant. And if we talk about like if we drive a equation with respect to product, for example, here we have taken A as a reactant, like A is reacting, they are making a product, that is B. Now B is a product. How we'll be writing it? The rate will be B. It will not be in minus sign because it is forming, like it is a product is formed, it is not consuming, like it is not decreasing, or like there will no change in the product. A product is formed by the changing of the reactant, so there will be no change in it, so there that will be in a positive sign, like we are not showing it with a positive sign, but it will not be with the minus sign. So if we drive an equation of this, that will be delta B divided by the time, means with respect to time, that will be an equation with respect to product. Now if we talk about the graph, like we are showing the rate of change, the rate of reaction with the graph, for example, that is 10, 20, 30 and 40. It is 10, 20, 30, 40, and this is 0. Now for example, that is A plus B making a product C, that is reactant, that is product. For example, there is no reaction started yet, so the concentration is 40. The concentration of that reactant is 40, and the time will be 0 because as the reaction is not started, so there will be no time consumed. So if there is no time consumed, so the time will be 0. If the concentration is totally high, like there is no change yet, concentration is 40, like high, so the time will be 0. But as the reaction starts and the concentration start to decrease, as it start to decrease, the time will increase, and the concentration will decrease. So that is how can we like identify, show the rate of reaction with the help of graph, that the concentration is high and the time is 0, but as the product, like the concentration start to decrease or changes, the concentration change, there will be a change in concentration, the time increases. As when the time is 0, no product will be formed, like there will be no product, obviously when the reaction has not started yet, so no product will be formed. But as the time increases, reaction, the product will start to form. start to form. If we talk about the rate unit, first of all let's check the formula, that is delta x upon delta t. What is it? The change in concentration with respect to the change in time. That is its formula. Now what is the unit of concentration is mole per dm cube. As dm cube move upward, that will be mole dm inverse cube. There will be the inverse, so that will be a change in concentration divided by the unit of time is second. So that will be the unit of rate. Or we can also write it like this: mole dot dm cube inverse dot second inverse. That can also be a unit for the rate, as well as that can be also a unit of rate.